Engineered systems are designed to specification tolerances, the expected load range, the ordinary operating condition. They capture the center of the load distribution. But catastrophic failure does not come from the center, it comes from the tail, loads beyond the design envelope that the system was not built to absorb. Probability mass and damage capacity are not co-located in structural systems. Where nominal loads concentrate is not where destruction lives. Within the design envelope, structural damage is bounded and the system remains operable. Beyond it, damage is large, accelerating, and frequently irreversible. This asymmetry is the formal structure of engineering fragility. The damage function bends upward as load moves into the extreme. Small additional stress beyond the design limit produces large additional structural harm. The reliability model does not capture that bend. For a fragile structural component, damage does not grow proportionally with applied stress. It accelerates. A load twice as large does not cause twice the structural harm. It causes more, sometimes far more. Stress concentration factors amplify this curvature at notches, joints, and defects. Fatigue crack growth accelerates non-linearly as stress intensity increases beyond the threshold. Not all load distributions place the same probability in the extreme. Some decay rapidly. Extreme loads become very rare beyond design conditions. Others, governed by extreme value distributions, retain substantial probability of large loads far from the typical. For fragile systems, tail shape determines how often catastrophic load conditions arise. Standard safety factors derived from nominal load statistics cannot distinguish these two regimes. Load standard deviation does not capture tail structure. Two structural systems can have identical nominal load variance and identical safety factors, yet differ substantially in tail behavior. One places almost no load probability in catastrophic territory. The other places substantial probability there. For fragile engineering systems, what matters is what happens when loads stray far enough to cause irreversible structural damage. That is not what nominal variance or standard safety factors capture. Design envelope analysis misses tail structure entirely. The tail of the load distribution is not simply a region of low probability. It is where qualitatively different structural outcomes live, outcomes the reliability model was never designed to represent. A system that absorbs moderate overloads may fail catastrophically under an extreme one. Structural ruin is not a scaled version of normal degradation. Reliability models built on nominal loading fail at the extremes, exactly where consequences are most severe. The tail exists, has structure, and carries a different kind of harm.